All right, so what I'm going to do tonight, right now, I'm going to make a video on Chapter 7. Some of this will repeat on what I said in class. For that, I am sorry. But this video will be for all of Chapter 7. And so you have homework that says 7A and 7B, all right? And so I'm going to be looking for that when I see you on Friday, okay, on Friday. So the first thing I want to know that we're talking here about scatter plots, all right? And I think you know about scatter plots. We have a horizontal and vertical axis, and we have dots, all right? So first of all, I want to say the horizontal axis, or what we know as the independent variable, we call the explanatory variable. Remember, we used this term when we did experiments. Also, it was called the predictor variable, okay? And the vertical axis, all right, the vertical axis is the y, is the dependent, is the response, is what comes out. Okay, so we'll do a lot more with that in Chapter 8. Right now, Chapter 7 is more of an introduction to scatter plots, and we want to talk about the dots. Okay, so I want to I want to differentiate two words, and they are association versus correlation. Okay, both of them kind of talk about how the two axes correspond with each other. Okay, so association is a vague use. Okay, you're talking in general terms, and correlation is precise. Okay, so correlation, we're going to give you a number, all right? We're going to ask for a number. Okay, so if I was to ask you about the association between two things. So let's say that I wanted to know your height and your weight. So let's say I got your height and your weight, and I notice, and I just have a bunch of dots. I'm putting more dots on here. I don't know if you can see those little. So anyway, I just did a whole bunch of dots. All right? And so what do you notice here about the association? So when I ask for the association, I want form, which is either going to be linear, quadratic, it could be a sine wave, okay? Your parent functions, all right? I want to know about direction. Okay, and that's going to be positive or negative. And let me see, they were talking about how strong it is. So I have form, direction, I don't know what to call this, type. And so this is where you have a strong association, a weak association, maybe even a moderate, or no association. Okay? Now let's look back over here to my height and weight. Do you see that the dots are relatively close to each other? So if I was to ask you to describe the association between height and weight, so let me get another pencil here. So if I was to ask you to describe the association between height and weight, I would say that there is strong, positive, right? Because if I was to draw a line there, it would have a positive slope. Linear association between height and weight. Okay? All right, so now let's go to correlation. So basically with correlation, that we're always between -1 and 1. Here's 0. Our magic numbers are -0.8, -0.5, +0.5, and +0.8. Okay. If we are between 0.8 and 1, we say we are strong. If we say that we're between 0.8 and 0.5, we say we're moderate. And if we say that we are between 0.5 and 0.5, we say we are weak. Now, as a special case, if we get 0, which I have never seen, there is no correlation. And for -1, trying to get this so I could write perfect. That's y equals mxb with a negative slope. And then this is also perfect. P-E-R-F-E-C-T, okay? So if I was to ask you about a correlation, so that means I gave you the number 0.58. All right, so you would say that there's a positive, moderate correlation between the two numbers. Now, correlation only works if it's linear. So it has to be a line. All right, so let's write down the rules about correlation. Okay, so the rules for correlation. It has to be linear. Okay, we donate the letter R for correlation. That is always going to be between -1 and 1. And it has no units. All right, so, and this is something that I explain in class, so I'm just going to tell you, if you weren't there, you're just going to take my word for it. If we were to swap the axis, so let's say height becomes weight and weight becomes height, you still get the same correlation. So we get the same correlation if you swap the axis. Okay, if you swap the x and the y axis, and if for height you went to centimeters, and for weight you went to grams, okay, if you change to units, it remains the same. So we get the same correlation if we change units. All right, so areas where you have to be careful. Okay, so something can have an association, could have a strong association, but no correlation. Okay, now how can that happen? All right, so here's my coordinate plane. Okay, can you see my dots here? Hopefully you can see my dots. And do you see that the tights are all very close to each other? So this has a strong association. But what can you tell me about the correlation? That my dots form a concave down parabola. All right, so therefore it's quadratic. And what does correlation have to be? It has to be linear. So there is no correlation. So you got to be careful with this. Would I do this to you? What do you think? All right, so beware of my traps. Another thing is correlation doesn't mean causation. Okay, so just because it has a strong correlation doesn't mean that it's going to happen. So just because I heard this one time that that people who believe in Santa Claus are obese and obese, and so the reason why I got that. How did I get that? That typically somebody did a survey and they found out that countries that are primarily Christians, so in that case they believe in Santa Claus, that a lot of those people there are overweight. So you can't say that somebody who believes in Santa Claus is going to be overweight. All right. So this is my video here. If you have any questions, just ask me a question. And again, all the homework for Chapter 7 is due on Friday.